Hi, Year 10, so we're going to have a look at your multiple choice questions on your work, energy, power and momentum assessment. So let's take a look at the first question. So we have an object of mass 4 kilograms is moving with a velocity of 3 meters per second in a straight line. What is the momentum of the object? Okay, so let's sketch it out so that we can visualize what's happening. So we have an object that I'll represent with a circle. It's 4 kilograms in mass and it's moving with a velocity of 3 meters per second in a straight line. What is the momentum of the object? Well, momentum, symbol P, is equal to mass multiplied by velocity. The mass is 4, the velocity is 3. That gives us 12 kilogram meters per second, which gives us answer C. Okay, question 2 then. So we've got an object of mass 80 grams colliding with another object of mass 40 grams. After the collision, P and Q stick together and then travel on together. Before the collision, P is travelling at a speed of 6 meters per second and Q is at rest. What is the speed of P and Q after the collision? So let's sketch this out as well. I'm going to do before to start with. So here's P, it's 80 grams, and we're told that P is travelling at 6 meters per second. Okay. Q is only 40 grams, and before the collision, Q is at rest, which means not moving, so the speed is 0. Let me realign this a little bit. So we then know afterwards they stick together. Okay, they stick and travel on together. So after the collision, we now have a larger overall mass where we've got P plus Q, and together they make 120 grams. And we want to know the speed after the collision, so V, which is unknown. Now, we're going to use the principle of conservation of momentum. So, total momentum before the collision must equal the total momentum after the collision. Okay, so let's have a little look and see what we've got individually. P has momentum mass multiplied by velocity because we know that that is what the momentum equation is. So we've got 80 multiplied by 6 here, and Q is 40 multiplied by 0, which is just 0, so this doesn't have any momentum. After the collision, we've now got a new mass of 120, but we don't know what the velocity is. Okay, so we've got 80 multiplied by 6 gives me 480, and that must be equal to 120V, okay, because the total momentum before the collision equals the total momentum afterwards. So all I do is I rearrange and I say, okay, well V must be equal to 480 divided by 120. And when I do that, I get 4 meters per second, which if you have a look back at the question, that gives you C. Okay, so that's number 2. Let's have a look at number 3. So, to calculate the power produced by a force, the size of the force must be known. What else needs to be known to calculate the power? Okay, so we are looking specifically at power, which we know by definition, power is energy transferred over time taken. Energy transferred is also work done over time taken, and we know that work done is equal to force multiplied by distance. So I can replace the work done, and so I know that power is also equal to force multiplied by distance divided by time. So I do need the distance the force moves because I need to know that, and I do need the time for which the force acts, because all of those things are in our power equation, and so therefore you should be choosing answer A. Okay, number 4. Brakes are used to slow down a moving car. In which form of energy is most of the kinetic energy converted as the car slows down? Okay, so to slow a car down, we apply the brakes, okay, and that applies to the car's wheels. And so what happens is there's friction between the brakes and the car's wheels. Okay, if we have friction, we get heat loss. And that is the main method of slowing a car down. And so the kinetic energy that we have must be converted into heat. And another word for heat is thermal. So we're going to choose C for thermal energy. Question 5 then. A man carries 20 tiles from the ground to the roof of a house. Each tile has a mass of 1.2 kilograms. The roof of the house is 15 metres above the ground. Okay, so here's the house. We know that tiles are being carried from here at the ground to the roof. Okay, and we're told that that is a height of 15 metres. Clearly, the tiles that are starting down here and ending up here are gaining gravitational potential energy, okay, which we know is given by mgh. How much work does the man do is how much energy is transferred against gravity. That's the gain in gravitational potential energy. So we need to work out what the total mass is, because each mass has, each tile has a mass of 1.2 kilograms, but he's not just carrying one, he's carrying 20. So mass is going to be 20 lots of 1.2. G is acceleration due to gravity, that's just 10. You're asked to remember that for this exam. And h is the height moved, and we're told that that's 15 metres. Okay, so you should see that 20 lots of 1.2 is 24. So mgh is equal to 24 multiplied by 10 multiplied by 15. And when we do that, we get 3,600 joules, and that gives us answer D. A bit. So we've got question 6. The diagram shows part of a roller coaster ride with the car at different positions. The car runs freely from position X, so here, to position Y, down here, and then up the hill on the other side. We are being asked what happens to the kinetic energy, so that's the movement, a half mv squared, and the gravitational potential energy, which is mgh, as it moves from position X to position Y. Okay, hopefully you can see that X up here is at a height above position Y. So there must be more gravitational potential energy at the top and less gravitational potential energy at the bottom. Okay, because we're at a lower point in space. We're at a height at X, we're not at Y. So we know then that if we're going from more to less, this is decreasing. Okay, so we know that GPE must be decreasing, so we can get rid of any that say it's increasing to start us off. Okay, we then need to think about where that energy is going. So obviously there will be some heat loss, but predominantly what happens is as this car starts to fall, it speeds up, it accelerates due to gravity. If it has a larger speed as it is gaining speed, it must also have a larger kinetic energy. Okay, so therefore it must be that you choose C. Okay, which energy resource in question 7 does not have the sun as the original source? So think about what coal is. It's a fossil fuel, it's fossilised, plants and animals. Okay, so over a very, very, very long period of time, dead plants and animals are put under a lot of pressure, forming coal. We know that animals eat plants, and we know that plants photosynthesize and get their energy from the sun. Okay, so therefore coal does have the sun as the original source. Geothermal energy is energy, if this is the surface of the earth, not a very good picture, but you get the idea. Energy that is trapped underneath Earth's surface is used to heat water. So what we do is we send pipes, we transfer water down underground, close to where the heat is. The water heats up, and we then take that as steam and we use it to drive turbines. This has nothing to do with the sun. Okay, geothermal energy does not have the sun as the original source. It uses Earth's energy stores. Just for clarification, with hydroelectric power stations, we have water travelling down a hill into a reservoir. So if this is your hill here, as it's nice and sunny, the water evaporates. Think about your water cycle from chemistry. That's then stored in clouds. The water then rains. As it rains, the water is collected at the top and it flows down. That water then passes through a turbine and makes the turbine spin, and we can produce electricity that way. Without the sun, we don't get the evaporation, we don't get the water at the top. So the hydroelectric power stations do have the sun as the original source. And then lastly, with wind turbines, what we have is the sun will be heating up air particles, and as that happens, they gain energy, they move faster, and that is different to the cooler air that hasn't been heated by the sun. And because we have different densities, we set up convection currents, and the air moves around as wind. So the sun is required for wind as well. So question 8, a woman of mass 50 kilograms has 81 joules of kinetic energy. What is her speed? Okay, well, let's start by writing the kinetic energy equation. So kinetic energy is given by a half mv squared, and we're told that that totals 81 joules. So we have a half multiplied by her mass, which is 50, multiplied by v squared must equal 81. So a half of 50 is obviously 25. So we have 25 v squared equals 81. If I divide both sides by 25, I get v squared by itself. I need v though, because I need speed, I need velocity. So I'm going to square root v squared, which gives me v, but that must mean I also have to square root 81 over 25. When I do that on the calculator, I will get 1.8 meters per second. So you can check that, and that will give you answer C. Okay, so we write out what we know, we rearrange to get the thing that we need. We don't want v squared, so we have to square root it. But if we square root this, we also have to square root the other side of the equation. Okay, and that gets us 1.8 meters per second. So, number 9 then. A solar panel is used to recharge a battery. The solar panel produces 0.8 watts of electrical power. So we want electrical power, so therefore this value here is the useful output. And it helps if you label this to yourself so that you don't make a mistake with the numbers. Okay, the panel is 20% efficient. What is the power input of the sunlight onto the solar panel? Well, 20% as a decimal is 0.2. I know, by definition, if I move this up just for a minute, that efficiency is given by the ratio of the useful power useful power output, so what we're getting out, compared to how much power we had to put in. Okay, and as a decimal, I know that in this case the panel was 0.2 efficient. Okay, 20% efficient, but I'm writing it as a decimal so that I can just look at the ratio. Now, I know that useful power output is 0.8 watts, so I can say 0.8 over the total power in is equal to 0.2. Okay, if I rearrange this equation, I can get total power input, and that is what I'm being asked to find. Okay, so I'm going to multiply both sides by total power input. So I will get 0.8 equals 0.2 multiplied by total power input. Okay, but I don't want that. I actually want total power input, so now I need to get rid of the 0.2 from this side. Okay, so what I'm going to say is 0.8 divided by 0.2, because I've divided both sides of the equation by 0.2, gets rid of this on this side, equals total power input. Okay, 0.8 divided by 0.2 is the same as 0.8 multiplied by 5. You can do it on the calculator though, you've got that. And you will get a value of 4 watts. And if we have a look, we've got that option, so we choose answer B. Okay, total power input is 4 watts. Last but not least, on your multiple choice section then, a force F acts on a body, and the body moves a distance d in the direction of the force. What expression for work done is correct? This is a very straightforward one. There's nothing to do except for to remember that work done is given by force multiplied by distance, and that's just something you have to commit to memory, and then you'll easily get that mark, and that gives you answer A.